is problem 2. It is suggested that the following functions of v a f v equals to e to power of negative absolute v, b f v equals to sine v squared over v squared, c f v equals to 1 if absolute v is smaller than or equal to a, and f v equals to 0 if absolute v is larger than a. May represent an autocorrelation function of a WSS stochastic process by setting v equals to tau, or a spectral density function by setting v equals to omega or both, which functions fv may represent either or both. Explain your answers. So for A, fv equals to e to power of negative absolute v. F negative v equals to e to power of negative absolute of negative v. So we can get fv equals to f negative v. Then we can get e to power of negative absolute v is smaller than or equals to e to the power of 0, which is 1. Thus, fv equals to e to power of negative absolute v is even and non-negative. Also, so we can get a may represent an autocorrelation function of a WSS stochastic process, and e to power of negative absolute omega is larger than or equals to 0. So a may represent a spectral density function. So for part B, fv equals to sine v squared over v squared. F negative v equals to sine negative v squared over negative v squared. So we can get fv equals to f negative v. Sine v squared over v squared is smaller than or equals to limitation of sine v squared to over v squared, which is 1. Thus, fv equals to sine v squared over v squared is even and non-negative. Also, so B may represent an autocorrelation function of a WSS stochastic process. Also, sine omega squared over omega squared is larger than or equals to 0. So we can get B may represent a spectral density function. So for part C, fv equals to 1 if absolute v is smaller than or equals to a, and the fv equals to 0 if absolute v is larger than a. It's not negative, non-negative. Also, so we can get fv of c may not represent an autocorrelation function of a WSS stochastic process. Also, f omega is larger than or equals to 0. So we can get C may represent a spectral density function.